Hi, this is Miss Frazita, and we are looking at 3.3 today, Rules for Differentiation. Okay, let's start. Well, first of all, I wanted to just make sure people were clear about what different types of functions are. And I'm using the word type kind of loosely, but if you think polynomials versus roots versus rational equations, you've got trigonometric equations, you've got logs, you've got exponentials. So as you're moving along in the years in math, you are introduced to more and more different looking things. So in chapter 3, and we'll spend a while on chapter 3, a good chunk of first semester, what we're looking for is basically the derivatives of all these different types of functions. And when we have a different type of function, we're going to need a different formula for derivative. I should also say that this is the section where finally you do get the power rule that I think a lot of you guys are fond of. So right up until now, you've been finding derivative with the limit of the difference quotient. And finally, now we get a shortcut instead of having to do the limit process. Okay, so today for section 3.3, our focus is going to be specifically functions that are polynomials or functions that are rational. So we are going to learn the shortcut, how to take the derivative of those types of functions. And by the end of chapter 3, you'll know how to do the shortcuts or take the derivatives of all of these ones that were listed in red a minute ago. You know, trigonometric, logs, exponentials, and so on. Okay, so first one, power rule. Everybody's fond of this one because it's so nice and quick. So if you have a polynomial function, or really any function where x is raised to the nth power, and it's not even just polynomials because polynomials have exponents that are just whole numbers, right? But n could be any integer you want, and even a rational number. So you just have your variable raised to some power. And the power rule says the derivative will equal, okay, and my notation here, this is the derivative of x to the n, so my function is x to the n. So the derivative, you would bring the n down, rewrite the x, subtract 1 from the exponent. So here it is, if our function f of x is 5x squared, then its derivative f prime of x will be 5 times, and then again the power rule, so the 2 comes down, x raised to the subtract 1 is now a 1, so I get 10x. I put a little note over here, my coefficient 5 that's out in front, you just leave it out in front, it gets multiplied by this n that comes down in front right there. Okay, so if I have multiple terms, here's 1, 2, 3 terms. Remember, terms are things separated by pluses and minus signs. So I have 1, 2, and 3 terms. If I want to take the derivative, I use my power rule on each term. So the 2 stays, I bring down the 3, x to the, and I subtract 1, it becomes a 2. So my first term's derivative is 6x squared. I keep going, so 4 times x. So the 4 stays in front, and then this is really an x to the first power, so you could think of bringing the 1 down, x to the subtract 1, so the 1 power becomes a 0. Anything to the 0 is 1, so really this is just 4. So you can kind of memorize that whenever it's a coefficient x to the first power, the derivative is just the coefficient 4. Okay, and then I have a constant on the end, and the derivative of any constant is always 0. So if there's no x there at all, you can't really do power rule because you don't have an x, so you can't look at the power of x. So if it's just a constant, the derivative will be 0. So simplify it. Here's my answer for the derivative. The last one down here, so I have 1/3 x to the negative 1. So this time the exponent is negative. It still works. We can still do power rule. So the 1/3 stays out in front. Bring the negative 1 exponent down, x to the subtract 1. Make sure you can subtract negative numbers. So -1 minus 1 is -2. And I got my answer. Okay, and I wrote it with the x to the negative 2 in the denominator just to simplify it. Okay, so that is power rule. We have product rule in this section also. So instead of having just x raised to a power, we actually have something here, my u, something with a variable x in it, and over here the v, something else with an x in it. So you're multiplying something with a variable times something else with a variable, and over here this is our notation for saying that we want to find the derivative of that. So what it equals will be the first thing, u, times the derivative of v, that's the second part, plus v times the derivative of the first part, u. Okay, so probably makes a lot more sense with a few examples. So let's look at example 4. Here's my function f of x. Notice how I have a product. I have x plus 1. That would be like the u in this equation. And I have 2x to the fourth plus 1. That would be like the v in this equation. So if I follow my little formula over here, it's the first thing, which is u, times the derivative of the second thing. So my first thing, which is u, here, x plus 1, I just copy it. And then I have to take the derivative of this part, which I'm calling v. So this part, I take the derivative with power rule. So again, the 2 stays there, the 4 comes down, so 2 times 4, 8. X to the subtract 1 is 3. Plus, and now I'm doing this part over here. So my second part times the derivative of the first part. So the second part is 2x to the fourth plus 1. The derivative of the first part, derivative of x is 1. Derivative of a constant 1 is 0. So this really, the whole part in parentheses, derivative is just 1. And then the rest of it, I just gathered up my like terms and I got my answer. Okay, let's try one more. So here we have x plus 1, whole thing squared. Well, if you want, you can think of that as product still. X plus 1 times x plus 1. So with my product rule, I have the first thing, x plus 1, times the derivative of the second part. Derivative of x is 1, derivative of 1 is 0, so 1 plus 0 is 1. Plus the second thing times the derivative of the first thing, 1 again. Clean it up, I get my answer. Okay, so that is product rule. The main thing I guess I want you to realize is that product rule really means a product of two things that are variables. So if I were to change this first example here, and instead of x plus 1, I just call it 5, and there's no x in there, it's just 5. That is not product rule. The 5 would be considered a coefficient. You can just leave it out in front, and you can just do power rule with this part here and make sure you distribute the 5 into your answer, and that's all you would have to do, just power rule. So product rule, you really don't want to have to use product rule when you can use power rule, because power rule is so much nicer. You use product rule specifically when you have a variable or something with a variable in it being multiplied by some other variable. So here's something with an x in it. Here's something with an x to the fourth in it. That would be when I use it. The other thing I was going to say before we move on is this first example, it actually wouldn't be too bad to just multiply it out, use FOIL, first outside, inside, last, multiply this thing out, expand it. And if I did that, then I actually wouldn't need product rule. I could just go ahead and do my power rule term by term by term. And I would get, hopefully, the exact same answer right down here. You can try it if you'd like. So this is basically what I was just saying. So let's say you have this function here, y, which is x plus 4 times 3x squared plus x. So our directions are find the derivative, and we're going to do two methods. One is the product rule that we just learned, and the other one, we'll actually multiply it out first, and then we'll find its derivative, and hopefully you can see that we get the same answers in the end. Okay, so the first thing, uv, I'll take the derivative, it's u, which is x plus 4, times the derivative of this part, so again power rule, so the derivative of 3x squared, the 2 comes down, 3 times 2 is 6, x to the subtract 1, I get 1. Derivative of x, again think of it as the 0 power, so I have a 1 out in front for the coefficient, 1 times 0x to the oh, I'm sorry, this isn't a 0, it's a 1. What am I saying? Coefficient is 1, x to the first power. So the 1 comes down, 1 times 1 is 1, x to the 0, anything to the 0 is 1. So I just get 1. Oh, okay, plus the second part times the derivative of the first part. Again, derivative of x is just 1, derivative of 4 is 0. Clean it all up, you get this. If I compare that to multiplying it out first, again, I would FOIL it out. So x times 3x squared is 3x cubed, and so on, right? Outside, inside. So outside is x squared, inside is 12x squared. That gives me 13x squared. And the last terms gives me 4x. So here's my equation, my original function y. Now I use power rule to take the derivative. So 3 comes down, 3 times 3 is 9, x to the 2. 2 comes down, 13, excuse me, 13 times 2, 26, x to the first. And here again, when it's just a linear term, it's the coefficient 4. And sure enough, they are the same. So kind of cool. You can pick your battles. You know, do you want to spend time multiplying this out, or would you rather just do product rule? Kind of just depends on you. Our last formula for today is quotient rule, and with quotient rule, again, you have something with a variable in it being divided by something else with a variable in it. So if these are constants, if u is a constant or v is a constant, you don't have to do quotient rule. You don't want to do quotient rule because quotient rule is longer than your option of doing power rule. So again, if your variable, something with the variable is up on top and there's something with a variable on the bottom, you need to do quotient rule. So here's my example. So the formula is the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. So the bottom thing is 3x. The top thing multiplied by the derivative of the top. So derivative of my first term is 4x. Derivative of the second part is 4, so 4x plus 4. Minus the top part, I just wrote it out, times the derivative of the bottom. Again, a linear term here, x to the first power. Coefficient is 3, that's just the derivative. All over the bottom squared. And you can kind of simplify it out. I'll let you look at that part. My second example, I just tried to make it even more complicated because on top here, there's a product. So this is going to be a quotient rule with whenever I need the derivative of the top, which is right here, this part of my formula, I'll have to do a product rule. Or I suppose I could multiply it out, but I'm going to stick with product rule because it's kind of fun. Okay, so we got bottom, which is the 2x plus 1, times the derivative of the top. So the derivative of this top with product rule. So x squared minus 1 times the derivative of this is 3 plus the second thing here, 3x minus 1, times the derivative of the first parentheses, which will be 2x. Okay, so in these square brackets that you see right here, that whole thing is the derivative of the top, u prime, okay, using product rule. So minus, and then it's the top times the derivative of the bottom. So the top is just the product again, derivative of the bottom. Well, the derivative of 2x is 2, derivative of 1 is 0. So it's just 2. All over the bottom squared. And I didn't even bother to simplify that one out. Okay. All right, so here's some practice problems. There's 3 of them. I put 1 of each type. Please do on number 2, use product rule just to make sure you can do that skill correctly. And I would suggest you pause the video, and then once you have them all worked out, go ahead and play it, and I have the answers coming up. Okay, so here are the answers. You can check yourself, see how you did. The first one here, when I look at the derivative of the first term, 3 times 6, 18x to the 2. Here, 2 comes down, negative 3 times 2, negative 6, x to the 1. Derivative of this linear term. When I say linear term, it just means the variable is to the first power. Linear meaning line. So here, this term, derivative is just the coefficient 2. And then at the end, the constant, derivative of any constant is 0. So that's my answer. This one with a product rule, I copy down the first part. I multiply by the derivative of the second part, which is the 6x squared minus 1. Plus the second part times the derivative of the first part. And okay, so here's the second part, derivative of the first part. 4 comes down, 4 times 3, x to the 3 minus 0. So here it is. And again, I asked up here in the directions, do not simplify, so just leave it. And for number 3, quotient rule, I have the bottom times the derivative of the top. The derivative of the top, I have to go term by term. So this part, 12x squared, this part, minus 4x, minus 1, and then a constant, derivative would be 0. So bottom, derivative of the top, minus the top part, just copy those terms down, times the derivative of the bottom again, power rule, 4 times 3, 12x to the third, all over the bottom squared. So 3 squared and x to the fourth squared. And I've got that. I didn't bother simplifying again. Hope that made sense to you guys. You know, most of tonight's homework is just going to be straight up computation, practicing your skill at taking the derivative with these formulas. So, thanks for listening.